I'm using Sklearn's QuantileRegressor to build a model. I've set the QuantileRe parameter to 0.5. This means I'm focusing on the middle value of my target variable, which is the median. This question is about what prediction my model will produce. This is correct. When I set QuantileRe to 0.5 in QuantileRegressor, my model predicts the median of the target variable, y, for a given predictor, x. Nope, this is incorrect. The QuantileRegressor doesn't predict the average, mean, of y. It predicts the median, the middle value. Think of it like this. The mean is sensitive to extreme values, while the median isn't. This is partially true. Because I'm focusing on the median instead of the mean, my model is more robust to outliers than ordinary least squares, OLS, regression. However, option D is better because it explicitly mentions the comparison to OLS regression. This is the most accurate of the statements. Outliers significantly influence the OLS regression, pulling the fitted line towards them. My QuantileRegressor, by focusing on the median, is much less affected by such extreme values. That's the advantage of using medians. I say this statement as true. Remember, we set the quantile parameter to 0.5, which directly corresponds to the median. The QuantileRegressor aims to predict the 50th percentile of the target variable, y, for each value of the predictor variable, x. That's the median. This is FALSE. We're using a QuantileRegressor, not a model that estimates the average, the mean. The QuantileRegressor focuses on a specific percentile, specifically the median when the quantile is 0.5. This statement is true, although statement D is a more precise way of expressing this. Outliers have less influence on the median compared to the mean. Since the QuantileRegressor predicts the median when quantile equals 0.5 it's less swayed by extreme values. I agree, this is true. Ordinary least squares, OLS. Regression minimizes the sum of squared errors. This means large errors associated with outliers heavily influence the model's parameters and, consequently, the predictions. However, the QuantileRegressor is much less affected by these extreme values because it targets a specific quantile, the median in this case. I'll explain the core idea behind Sklearn's QuantileRegressor. It's a powerful tool that lets you predict, not the average, mean, value, but a specific quantile of your target variable. Think of it like this. If you set the QuantileRe to 0.5, you're asking it to predict the median, the middle value, of your data. When you use QuantileRegressor with, you're specifically telling the model to focus on predicting the median value. This means, for a given input, x, the model will aim to find the middle point in your target variable, y. This is the core question. We're evaluating whether our understanding of QuantileRegressor with is accurate. Let's analyze each statement carefully. This is absolutely correct. Setting directly targets the median, making it the model's prediction. This statement is incorrect. QuantileRegressor isn't designed to predict the mean, average, value. That's the job of other models like linear regression. This is partially true. QuantileRegressor is generally more robust to outliers than OLS regression because it doesn't directly minimize the squared error, which can be heavily influenced by outliers. But it is better described by the next option. This is the most accurate statement about outlier robustness. By focusing on the median, QuantileRegressor is less swayed by extreme values in the data than ordinary least squares, OLS, regression, which tries to minimize the sum of squared differences, and that's massively impacted by outliers. I like this one because of comparison. I'm explaining the core idea behind this question about the Sklearn's QuantileRegressor. We'll be figuring out what it does and how it handles data, specifically focusing on how it works with the quantile parameter. This statement says that when you set quantile to 0.5 in QuantileRegressor, the model will predict the middle value, median, of the target variable, y, for any given input, x. Think of it like finding the exact center point of a bunch of numbers. It's the value that separates the upper half of the data from the lower half. This is wrong. The QuantileRegressor with quantile equals 0.5 doesn't predict the average, mean, value. The mean is calculated by adding up all the values and then dividing by the number of values, while the median is the middle value. This is correct. Outliers are extreme values that are far away from the rest of your data. Ordinary least squares, OLS, regression is very sensitive to these because it tries to minimize the sum of squared differences between predicted and actual values. Since outliers have large squared differences, they heavily influence OLS predictions. QuantileRegressor, on the other hand, is much more chill about outliers. It focuses on a specific quantile, like the median, so extreme values don't have as much sway. That makes it more robust. I'm setting the quantile parameter to 0.5 in the QuantileRegressor. This means the model will predict the median of the target variable, not the average, mean. Think of it like finding the middle value when you arrange all the target variables' values from lowest to highest. That's the median. OLS stands for ordinary least squares. It's a method used in linear regression. The QuantileRegressor is designed to be less influenced by unusual data points than OLS regression is. Extreme values, or outliers, in the data can strongly skew the results of OLS regression. However, the QuantileRegressor cares less about these outliers because it focuses on a specific quantile, in this case, the median. This statement is partially true. The model is robust to outliers because it predicts the median, not the mean. The mean is easily affected by outliers. The median is less affected. However, statement D provides a more precise comparison. This is incorrect. I'm using a QuantileRegressor with quantile equals 0.5 . It directly predicts the median, not the average. The median and mean are only the same if the data is perfectly symmetrical. This statement is correct. The quantile equals 0.5 setting in the QuantileRegressor makes the model predict the median of the target variable. I selected this quantile precisely to find the central tendency. This is true. The QuantileRegressor's strength lies in its robustness to outliers compared to OLS regression. OLS regression is very susceptible to outliers because it minimizes the sum of squared errors, heavily weighting extreme values. This is the central question. I want to know which statements are true given that I am employing Sklearn's QuantileRegressor with quantile equals 0.5 to model the relationship between an independent variable, x, and a dependent variable, y. The key here is understanding the implications of using the median instead of the mean. We are discussing quantile regression, a statistical technique focusing on specific percentiles or quantiles of the dependent variable, unlike typical regression which focuses on the mean. I see, this is a multiple-choice question about the QuantileRegressor in Sklearn. We are given that the quantile is set to 0.5, and we need to determine which statements accurately describe this model's behavior. This statement says that the model predicts the median of the target variable, y, for each given value of the predictor variable, x. This is correct because setting specifically targets the median. Think of the median as the middle value in a sorted dataset. This statement claims the model predicts the average, mean, of y for a given x. This is incorrect. A QuantileRegressor of 0.5 means the model focuses on the median, not the average. The mean and median are only the same when the data is perfectly symmetrical. This statement is partially true. The QuantileRegressor is indeed more robust to outliers than ordinary least squares, OLS, regression. But statement D provides a more precise comparison. This statement correctly points out that the QuantileRegressor is less affected by extreme values, outliers, than OLS regression. OLS regression minimizes the sum of squared errors, which makes it highly sensitive to outliers. The QuantileRegressor, by focusing on a specific quantile, is more resilient. Imagine trying to find the middle of a line. A few very far points won't dramatically change its middle, but in calculating the average, mean, those far points will pull the average a lot. I'm asking you this question to test your understanding of the Sklearn QuantileRegressor. We'll explore the properties of this model. I'm using the QuantileRegressor from the Sklearn library, setting the quantile parameter to 0.5. This means I'm focusing on the median. This is the variable that I'll use to predict the target variable. This is the variable I want to predict using the predictor variable. Because I set the quantile to 0.5, my model will predict the median of the target variable for a given predictor variable value. This is a type of regression model that's particularly useful when you are interested in predicting specific quantiles of the target variable distribution, not necessarily the mean, and when outliers might be a concern. This question tests your understanding of the QuantileRegressor and how the choice of quantile parameter influences predictions and robustness to outliers.